Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAIZ bin HAIRANI. So our group member consists of 4 members, which is Muhammad ZAKWAN bin Muhammad ZUBAIDI, Muhammad Haekal bin SHARIMAN, and NAIM RIZUAN bin ZAID. So the topic for this project is generation of different power quality disturbance and their respective mitigations. So we go to the first part, which is introduction. So the power quality disturbance are given into 6 parts. So the first part is impulse transient. So the source is lightning, electrostatic discharge, load switching, capacity switching. And the effect is tripping, processing error, data loss, burn circuit boards. And then the second part is oscillator transients, which is the source from line or cable switching, capacitor switching, and load switching. So the effect for the oscillator transient is same with the impulse transient. Next, the voltage surge or swells, the source from remote system faults. So the effect we get is memory loss, data error, dim or bright light, shrinking display screen, equipment shutdown. And fourth, under or over voltage. So the source from motor starting, load variation, load dropping. And then the effect cause shorten life of motor and lightning filament. Next, we go to part 5, which is harmonic distortion. So the source from nonlinear load and system resonance. So the effect is continuous distortion of normal voltage and random data errors. So for the last part for power quality disturbance is voltage flicker. For the source, first intermittent load and motor starting and also arc furnace. Again, the effect from the source, visual irritation, introduction of many harmonic components in the supply power and their associated equipment. Okay, next we go to the objective. So the objective in this project are given into 3 parts. So the first objective is to understand the generation of power quality in electrical system. Second, to understand the cause and effect of power quality towards end user. And third, to mitigate the power quality disturbance in power quality problems in this project. So that's all from my part. My friend will continue to present the next part, which is methodology.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ZAKWAN bin Muhammad ZAID. My matrix number is CE1900X1. Okay, today I will explain about the methodology. First of all, to achieve the desired outcome, a number of procedures include in the technique for the simulation of the study. To interpret the problem, several methods are also needed. It is necessary to simulate the harmonic proceeding load and the filter that reduce it. SIM power system toolbox and MATLAB software are the two that are absolutely necessary to do the work. For the task to be complete successfully, accurate and precise analysis are essential. Okay, first, for the MATLAB software, the framework for creating programming system, particularly for engineering and scientists, is called MATLAB software or MATLAB language. A metric-based language that enables the most natural application of computational mathematics must be used and addressed in order to use the MATLAB software efficiently. For technical computing, it is a high-performance language. In addition, it combines computation, visualization, and programming in a user-friendly setting where issues and answer the given using standard mathematical notation. The MATLAB scripting language serves as a foundation for MATLAB application, the deployment of command window in the form of an interactive mathematical shell, or the execution of files that contain MATLAB code are two typical use of this MATLAB application. Then for the SIM power system toolbox, for modeling and simulating electrical power system, SIM power system toolbox offer library and component part and analytical tool. Model of electrical power component are included in the library, including electric drive, three-phase machine, and component for application like flexible AC transmission and renewable energy system. The essential study of the electrical power system, including load flow, harmonic analysis, and total harmonic distortion (THD) calculation, are automated to create control system and evaluate system performance. Simple system model can be employed. MATLAB variable and expression can be used to parameterize your model, and Simulink can be used to develop the control system for your electrical power system. Next, we go through to the flowchart. We start and then we simulate and run the model and then show the output, then satisfy of the output. If yes, we analyze and record the output result in the end, and if then no, we will return to the simulate and run the model.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haekal bin SHARIMAN and my metric number is CE190090. So today I will be doing the simulation for overvoltage transient through surge arrestor. So basically in this circuit consists of MOV, which is the metal oxide varistor, and here is the series capacitance, and here shown is the shunt inductor. So to observe the overvoltage transient, first one is we proceed without the fault. So start the simulation, and here shows the scope for the series capacitance. So as you can see here, the voltage here is the voltage versus time graph, and here is the current versus time graph. This is the current for MOV. So for the voltage, as you can see here in the waveform for the voltage swell from 0 until 0.1 and then begin to clear from 0.1 until 0.2. So during the highest peak at 0.042, the voltage value that we get is 7.205 kilovolt, and it is at the highest for the current value. So next one is for the scope at the shunt inductor here in the scope 2. This is the graph for the voltage and for the current. As you can see here, the value of the current at the highest peak is at 0.105 time, and we can observe that the voltage waveform is become unstable. So this is for the without fault, the overvoltage transient through surge arrestor without fault. So the next one is how the simulation when the fault is connected. So we run the simulation. So for the series capacitance, as shown in the voltage graph here, it is observed that there is a voltage swell from 0 to 0.1 second and then begins to clear from 0.1 until 0.2. This is due to the protection of the MOV, and during that time the current value is equal to 0 from starting time of 0.04. So during the clearance value, the voltage is at the highest peak of the voltage reading, we get at 3.121 kilovolt. And then for the shunt inductor, this is the graph. So the first one is the graph for voltage. As we can see here, the output waveform is normal until it reaches at the point of 0.103 at the value of 1.056 exponent -5, and we get the current value is equal to 0. So I think that is all for the voltage and current waveform for the over voltage transient through the surge arrestor. Thank you.
Warahmatullahi wabarakatuh. My name is RIZUAN bin ZAID. My match number is CE190070. So today I would like to present the simulation for task 2, which is simulation of harmonic, producing load and mitigating filters. So simulation is by using MATLAB. So these are the harmonic filters in Simulink. There are few components that are used in the circuit, which is three-phase generator, power transformer, rectifier, DC generator, pulse generator, and three-phase harmonic filters, which is contain a C type, double tune, and also high pass filter. It is connected parallel to the capacity bank and connected also to the circuit breaker. So in task 2, we have two conditions, which is with and without filter. So let's proceed to the first condition, which is without filter. So our selection will be in open, apply, okay, we run. So we get the output voltage around 442.02 kilovolt. Meanwhile, for the ampere is 1.07 kilo ampere. So let's see the waveform. As you can see, without using the filters, there is distortion within the waveform. So how we can overcome this? By filtering using the new circuit. So first of all, we close the circuit breaker, apply, okay, and we run the simulation. We get the output voltage is around 499.22, approximately to 500 kilovolt, and the output current is 2 ampere. So this is the output waveform. So as you can see, it is improved the waveform by using the filter, and it helps to remove the harmonic distortion occur in the power system. Okay, next, let's proceed to the FT. Okay, we keep the power going and select tools for FT analysis. We start with the without. Open, apply, okay, run. We select the FT analysis. Okay, compute FT. So this is the without filters. Next, for the filters, close, apply, okay. Select for the FT analysis. Select for analysis, run. Tools, analysis, compute. Okay. As you can see, in this FFT signal, this the initial without filters, and this the final results for the simulation. So as you can see, the THD in this simulation decreasing after applying the filters, which is from the 13.6% to 11.50%. So next, let's proceed to the waveform. How can we generate the output waveform impedance vs frequency? It is same with as the FFT analysis, which is we have to open first the circuit breaker, apply, okay, and run. So create this and we put in the measurement. So as you can see, we put plot at 6 hertz. We get the impedance is around 416.67. As you can see, this is the total reactive power. By applying the formula, we can get the final value is 600 mega VA. So that's all from me. Thank you and assalamualaikum.
Okay, for the conclusion, based on the project, we can draw the conclusion from the project that we are able to comprehend how the electrical power system generate power quality. Average power quality issues in particular system disturbance can be observed in this project. The harmonic filter is used as a mitigation tool for the harmonic power quality disturbance, reducing or eliminating the harmonic to acceptable level. In addition, we are able to comprehend how power quality affect the end user. We also are able to reduce the power quality distortion in power quality issues in accordance with the instruction based on the simulation. Okay, that's all from me. Thank you.